Hey, this is Steven from LegitTechTutorials, and welcome to Intermediate Unity 5 tutorial series. So we are going to extend on what we learned on our beginning Unity 5 tutorial series. We are back working with our 2D game. And now what we're going to do is we're going to do a lot of code and optimization practices in this intermediate series to make our game run faster, easier to read, and also easier set up things so that it's easier for if you were a strict programmer. So let's say you're a programmer on this project, how you would have the game in an advanced in like a enterprise or like a small business setting. If you were making games, how you would hand off the game to a level creator or somebody else. So if you were designated to do all of the game development stuff, and then other people did audio or not UI. Well, yeah, I guess UI are the artists and storyboarders, stuff like that, and level designers. If you were to hand this game off to somebody else, what would you do in here to hand it off to somebody else so that they could work on it without knowing code and without knowing anything of this, without knowing basically anything you did, to where you could easily explain to them how to build 15 extra levels on this game within 15 minutes. So that's what we're going to do. Okay, so I did a couple things to fix the game, like some of the things I said I was going to fix. One thing is that I got the background to stop clipping. What you do is you go to background and set that to the default layer, or you can set it to the background layer and then go to this enemy AI. I'm actually in the game, so let me jump over here. This enemy AI, if you notice, I changed it to foreground. It used to be default, that's why it was in the back. You want to change this to foreground so it's out in front of everything. So that is the sorting layer of this AI enemy, this little arrow thing here. Then what you want to do is you want to go to canvas, and we had an issue of this hiding behind stuff. I think did I move my background? Okay, so I'm just going to leave that all the way in the back because otherwise it clips the canvas. But I'll show you guys how to change that. So what you're going to do is you're going to move this plane distance all the way down to about 17 or 14. You notice as I change the plane distance, that score pops in and out. That's because depending on the distance away from the camera plane, it will go past the background or in front of the background. So you just want that, you could even have it like super close in the negatives. And there it goes. It finally goes past where the camera is. So actually I'll have it way deep in the negatives. But it doesn't really matter. So I'll just have it right there. So that way everything doesn't clip. I also amplified this death animation, and I was gonna have it to where when you die, you click to go to the next. You touch your tablet, or you click to go to the next. Go to the next page, but it's not really that big of a deal. So what are we going to talk about in this video? We're going to talk about using the profiler to get better. To analyze our system performance, our game performance. So we're going to analyze where we could make better decisions as far as our code to better optimize. They call it optimizing our game to run on different platforms. So I'm going to show you guys two different places where you guys could use the profiler. I could either use it on my Android Tegra Note 7, or I could use it on my Playback Engine, which is here, this main Playback Engine. So let me show you guys what that looks like. Go ahead and hit Window, and you're going to hit Profiler, and this is what it's going to look like. So as you can see, this is super big. I do not want it that big. I actually want it to fit right here in this space. This audio portion right here is not very important. You could actually just kind of crush it all the way down to about here. And I can't crush this. Oh yeah, I can. Oh no, yeah, it just crushes everything. Okay, so I'm just going to have this guy down at the bottom here. And then what I'm going to do is to make sure your game is not maximized on play so you can see what's going on. So now I just have the active profiler set to my editor. And then now that I'm playing, you see that it starts to render the different stuff here. So it starts to pull in information, and what I'll do is I'll actually stop the game once I get to the end so it doesn't change at all. Okay. So this is a full run of one map, and here is all of our data logged onto one page. So let's go ahead and go through and analyze this really quick. Sorry, wrong button. I thought it was not all maximized. Okay. The main thing you want to look at is the CPU usage here at the top. Now, what this basically tells us is what different parts of the game are running at one time. So it is color coded. So here, Vsync is this like yellowish color. Purple is the GI garbage collector. It shouldn't really have much of a garbage collector, but it's like in here. Or actually, it should be down here somewhere. It should be very quick. Physics engine looks like to be the orange, which is a little bit up here. Scripts is blue, so blue's here. And then rendering is green. Very little rendering, as you see. It's a tiny little line there. Okay. So, basically what it means is that they have these lines drawn. Now, hopefully I can't actually make this bigger for you guys. Anyways, what you're looking at is you want to look at this guy here. And this basically says 60 frames per second. So anything that is below that line, as you see here, there's 100 frames and 200 frames per second. So FPS is frames per second, or 16 milliseconds. So it takes 16 milliseconds at this point. What you want it to be is at least 60 frames per second or lower. Or lower down here. So what I mean by lower, I mean like here. So it's flipped of what you would think. You would think, oh, I don't want it to be up here, but the truth is you want everything to be down here. You don't want it to be up here, you want everything to be down here. So what does that mean? That means basically anything that is drawn really close to this 60 frames per second line is executing at a rate of 60 frames per second. So that means that it's slower, it's executing slower than stuff here at the bottom. So one thing to look at, for an example, is the Vsync. The Vsync is this entire area. So what that means is it means that it's executing at different rates. So some of it's executing at 10 milliseconds, some of it's executing at 5 milliseconds. And that is the biggest usage. So basically what that is that Unity is capped at 60 frames per second. So basically what it does is it like bottlenecks your game so it only executes at 60 frames per second. But luckily for us, everything is on Delta time, so it's not going to cause any issues. It's going to be the same for everything. So you notice here, that's what's down here at the bottom. This is the hierarchy for everything that's happening, and it tells you the percentage of the CPU usage that it's using. So you notice here that it's waiting for the target FPS. The target FPS is 60 frames per second. So it's waiting for 60 frames per second, and that's using up 82% of all of our usage. So basically what that means, it means that the rest of our game is taking up 100 minus 82, so 82, so it's like 17.4. So our game's only taking up 17.4% of our CPU usage. And I have an Intel i5, it's a Ivy Bridge 3570K. And I have a 660 Ti NVIDIA. So that's not very much. That's taking up everything. And then you see here just our behavior update, character update, event systems, canvas scalars, stuff like that. So the character update is what's taking up most of it. Log string to consoles, strangely taking up a lot of stuff. Everything else is basically physics is absolutely none. Physics 2D is absolutely none. Very, very low usage everywhere. So on a PC, you don't really have to worry about it too much. But this stuff amplifies itself when you run it on a system. On a smaller system. For example, I have my Tegra Note 7, but this is probably still overpowered compared to what you're probably even used to seeing standardly. Unfortunately here, I'm about to run out of battery. But let's see if I could just draw one game here. So what I'm going to do is I'm going to go Active Profiler, Android, and then I'm going to launch my game really quick. And let's see if I could get it to run without having to jump. Let's see if I can get at least a decent run here. Okay, so it's not wanting to do that. Okay, so let me close everything so I don't run out of battery. And then what I'm going to do is I'm going to talk for a second here as I compile it to here. Actually, cancel that, cancel that. Okay, what I want to do is I want to make sure it auto connects profiler. And I'm just going to resave the APK. So I went into Android OS here and I made sure I hit auto connect profiler. So I'm probably only going to get one run. One run's fine for this particular thing. And you don't really need to see the tablet. All we're looking at is this profiler here. So it's just going to push it, and hopefully my tablet doesn't die. It's at like 6% right now, but I think we're good enough right now for one run, or maybe even half a run, as the charging system on this is not very good. Okay, come on. Yeah, so the objective of the profiler is to analyze what your what's taking up most of your usage. So some of my friends I know that I've talked to about them building games, very, very large 2D games, like huge 2D games. Alright, so let me make sure I'm on recording. Active Profiler Android player. And it's starting to launch. Okay, there you go. You see it right from my Android. There you go. And that is basically what we're looking at. Okay, so now that that's done, that's probably not the best run to look at, but let's take a look at it anyways and analyze it. So if you see, as you see here, it's a lot different as far as compared to what I did on my PC, as we have impacted hardware in this case. We have this is a Tegra 4, not the TK1, it's Tegra 4, or the TX1, it's Tegra 4, NVIDIA Tegra 4 embedded processor on my tablet, which is pretty high compared to most stuff. So as you notice here, it's actually almost very similar, but you see we have some jumps here, up to 30, even up to 15 frames per second. We have some random kind of slowdowns. So that's probably because of my system. And the another thing you have to worry about is that my system on this tablet only has 1 gig of RAM. So compared to everything else that you're running at one time, it only has 1 gig of RAM. Wait, let me just run this one more time. I don't know if it connected correctly. Oh, there it is. Okay, I'm opening the game. There it is. Okay. Now it's a lot better here. Okay, so I just stopped it there. Alright, so let's take a look again at it and analyze this data. Alright, so what we noticed is that we have total allocated is up here. So you notice that as I sweep across here, it says we have total allocated is only 71 meg. So I'm only using 71 meg of RAM, but that's because I have very little assets on screen. So some of my friends that have very, very large 2D games with thousands of assets on the screen at one time, it uses up a lot of RAM, and what it'll actually do is max your system out. So what if I had my system doing all different kinds of other stuff? Because it only has 1 gig of RAM, and then a lot of it's allocated to just running my OS and stuff like that. So, you know, that type of impaction you have to worry about. On a standard system like my desktop here that has 8 gigs of RAM, which is even low for even that type of system, it's still not that big of a deal. But on this type of system, which I'll tell you right now how much RAM I'm using on it right now. So right now I'm using 300 for my system, and my apps are running 180 megs of RAM. So that means out of 1 gig I only have 402 megabytes of RAM left, which is very little. And right here I'm using almost 100. So let me tell you guys that again, just in case you didn't quite understand the impaction of that. So I use 100 megs of RAM, for example. I'm just going to round this to 100, and I only have 400 available. So I just used up 1/4 of my RAM just to play this one game. So, for example, if you had 4 times the stuff on screen and 4 times the scripts, I wouldn't even be able to play it very well on my tablet here for 1 gig of RAM. So just something to think about. And luckily, Unity has this profiler that allows us to pull the information from our tablet and other devices to see how it's running. Okay, so memory is an issue, and also CPU is an issue. So let's go ahead and take a look here. Let me go ahead and push it all the way back here. All right, so again, 30 frame per second bar, 60 frame per second bar. We notice that we are still getting good 60 frames per second, and we do not have any sort of wait for target frames here. Oh, here we go. Wait for target FPS is only 0.2, so most of the time it's 60 frames per second anyways, so we don't need to wait for Vsync. So Vsync is almost non-existent. And also you notice that when we click on stuff, it will automatically highlight it. So here is the graphics preset in sync. And then this is type of stuff that you would have to look up. I'm not even sure what exactly these are. And here we have something, this is way past 60 frames per second. Not even worried about that. But this is working at 60 frames per second. So that might also be something that we need to minimize. And you see the stuff on top. This green is this guy, which is running at the 60 frames per second. We still have a couple bleeps up past 30 frames per second, probably all the way up to 15 frames per second. So that is also something that we need to minimize and figure out why it's doing that particular action. Alright, so rendering here, we have no issues rendering. So let's take a look. Draw call 6. Screen 6464. VRAM usage. We only using up 135 meg. So that's another thing about the system, is that the type of mobile stuff like tablets or phones, they usually have shared memory. Some have dedicated graphical RAM, and some have shared. So another thing to worry about is the more textures you store on the VRAM, the more like system memory you take up. So here 135, which is a lot. Okay, so here I have 148 assets, a couple audio clips, a couple animation clips, a couple materials, a couple meshes, a couple textures, 19 game objects in the screen, total objects in the screen 110, total object count 258. So at a peak, we are using on average around 72 megs. So now, using this information, we are going to keep this in mind, and it is stored. It's obviously going to be stored on YouTube for you to look back at how it played. But we are going to look at when we are finished with our game, optimizing it in this intermediate series, as far as looking at better code practices and using methods and whatnot in order to better view some of our code and also more code reuse, whatnot, to see how more stable our game is on mobile when we try to fix these spikes here, which are being caused by something in our game, to keep it completely smooth at 60 frames per second. Minimize how many assets we have, the size of assets and whatnot, to get it to where it is under 100 meg, where it stays under 100 meg for everything. Alright, so this has been a quick video at the profiler, just looking at the performance of our editor, or our almost like our playback engine, and also the Android profiler to look at how it plays on my Tegra Note 7. So, I will see you guys next video in the series. If you like the series, please subscribe for more videos like it in this series and other series as well, and I will see you guys in the next video. Have a good day. I'll see you guys soon. Thanks for watching.